Any questions? Okay.
I'm having a hard time with acceleration on the exam. My quick question is, if you're speeding up but going in a negative direction, would that be negative acceleration?
Yes.
If you're slowing down and going in a negative direction, would that be positive acceleration?
Yes.
So if you're slowing down, going in a positive direction, that would be negative acceleration.
That is correct. I feel like you want to make another comment.
No.
Not that you were going to, that you wanted to.
I just trying to make sure I'm understanding this correctly. But I guess I do have another question. What if you're speeding, is your direction determined for acceleration, is your direction determined from the starting point, or does that just not matter?
That does not matter.
At
It
all.
depends on how the velocity changes. So if the velocity, if the change in velocity is negative, acceleration is negative.
Uh-huh,
So if your velocity is negative, you're traveling in a negative direction, your velocity is negative, well, if the change is negative, that means you become more negative.
okay,
So you're speeding up.
yeah,
If you're on the positive side, then the change is negative, you go to a lower value, so you're slowing down.
but it doesn't matter from the starting, cause say the.
Does not matter.
Okay. So because you said to the right is positive, to the left is negative, so whenever it's traveling to the left, no matter where the starting point is, it's gonna be negative.
Velocity will be
Yeah,
negative.
velocity will be
Yes.
negative, okay. That's where I was having confusion, because I thought it was from the starting point, and I'm like, it can't go to a zero, cause it's speeding up continuously. So it would just be negative that whole section,
If it's the section I'm thinking of, yes,
okay.
if we're in sync.
I think we are.
Okay.
I still don't understand how, I guess, acceleration, when you have the analog scale, like when to know when it's going up or down.
As with any, if I'm standing on the ground here, I have two main forces acting on me. Weight, normal force. If I'm accelerating upwards, normal force is bigger. If I'm accelerating downwards, weight is bigger. And if I'm in equilibrium, they're equal to each other. So it comes down to a question of what is the direction of your acceleration? Tells you, I forgot what the.
Says when will that be accelerated up?
Okay. So if we want to go with that's positive, then your acceleration is positive. If you're traveling in the positive direction, it's speeding up. Or if you're traveling in the negative direction, it's slowing down.
That's what I thought. But it doesn't matter, there's no starting point or origin, like displacement and position has.
Yeah, that they,
Yeah. That doesn't matter at all.
velocity, acceleration do not care about where you are.
Okay. And then with the master set of ball two, I think you said that the one with the hole would win, but I don't understand why. Wait a second, I'm not getting why, because there's friction, I'm not understanding how that would help. Is it, no, they're the same mass, so.
Same mass, the different distribution of mass. So the moment of inertia depends upon how the mass is distributed.
I couldn't find the video.
Oh, the marble race video or the?
This was this problem was inspired by drag number 3.
Yeah.
Yeah,
Just as a side note. Those are L's, it's a J. Can't remember if Marvel runs one word or 2 words.
okay,
I think it's Yellen. It's one of the Scandinavian countries.
okay. So just look it up on YouTube?
Yeah.
Okay. I
And
was
it's
trying
the
to-
sand rallies specifically for red number 3.
I was looking up in all the videos that we,
On Blackboard?
yeah,
Oh, yeah, no.
okay, I was like, did I miss it?
I might have possibly I
I
have
watched
a,
all of them. I'm like-
Alright. It's possible I have a link in the Just for Fun, which I think is
Okay.
under supplemental.
Okay,
Maybe, I can't remember if I put a link to that.
okay,
Anyway, it's just a lot of fun.
okay, well,
Okay, so the greater the moment of inertia. So we take
yeah,
these two as examples. This has a lower moment of inertia. So you can tell because
Yeah.
I've got the darkened circles there. This has the greater moment of inertia.
yeah,
Now, in terms of starting and stopping, which one's going to be easier to start twisting?
this one,
Yeah. And stop twisting?
probably that one,
Yeah. So it's easier to get going, but it's also easier to stop.
uh-huh,
And in saying the translational analog, linear analog is the less mass an object has, the easier it is to get to
yeah,
moving, but the easier it is to stop it.
mhm,
So if I have something with a lower moment of inertia, it'll get going faster, but it also, which is the advantage for part A, but for part B,
it's the disadvantage.
yeah.
Okay, now I see,
So that's why,
okay,
yeah. Other questions? Okay. We left off last time with the question of what pressure can you break human skin? And I'm gonna look that up now. It's approximately 100 PSI. So this is the skin puncture pressure. I don't know if you want to word that. So first off, what is PSI? Besides a unit of pressure. If you ever inflated your tires, you inflated to probably 32 PSI.
Air pressure?
It is, but what does PSI stand for? Well, let's think about what is pressure anyway. Refer to your notes if you need to.
force of the area.
Yes. So I have some force divided by some area. So the P is the unit of force. What is our unit of force? The US standard. So P is for pound. And then SI is the area. S stands for square. I for it's an area, so it's a length times a length. What length do we typically work in here?
Is it for inches?
It is for inches.
We
So,
normally work in
this is a US standard here. So this is pounds per square inch. However, outside the US, who knows what, I watch enough British shows where they talk in miles, kilograms. They have sort of mixed. Canada also has a mix. So anyway, let's get this into metric though. So instead of pounds, we want newtons. Instead of square inches, what is the standard international unit for distance?
Meters?
Yes. So we want it in newtons per square meter. And if you recall from last time, what is a newton per square meter? Now, there is a one word,
Oh, Pascal.
yeah, Pascals, or Pascal. I've always heard it pronounced Pascal.
Yeah.
Okay. So we want to get this into pascals, in other words, a newton per square meter. So, I'll spare you. All right. First, pounds and newtons. What does that convert to?
4.45.
Say it again?
4.45.
It's somewhere around there.
Yeah.
All right, so I got 100 pounds times, I want to get rid of pounds, that's going to go on the bottom. Newton, so it's 1 pound is 4.45 newtons. And so I remember that the newton number is going to be bigger than the pound number because I have a little over 200 pounds and about 1,000 newtons. All right, so that'll get rid of pounds, that's per square inch. And then inches to meters. All right, let's do inches to centimeters first. How many centimeters per inch? The reason why I'm doing that is that's an exact number. You have to resort to looking it up. Not very engineering of you. So we'll get rid of inches, so that goes on top. And what's centimeters at the bottom?
This is 2.54.
Yeah.
Is that what you were looking for?
Yep.
Okay.
It is exact. The
Okay.
powers that be sat down and they said, we need to make these units back, we need to be able to go from one to the other. And they said, we will make the edict, 2.5 centimeters equals 1 inch. Presumably, that's close enough to what they were doing, and they just rounded it off and said, we'll make it stick. All right, and we have to square it because I have inches squared, so we've got to do it twice. And then I need to get into meters. How many centimeters per meter?
100.
100.
So the math problem is 100 times 4.45 divided by 2.54 squared times 100 squared. That's the math problem. That's a decimal point there. And we end up with the Martin number. Someone's about to reveal the answer. Any other question? Attention notes. Side bets are being made.
$689,751.38.
$689,000.
Yeah,
689,000.
751.38.
All right. So approximately 6.9 times 10 to the 5th pascals. That's 5. So the follow-up question is, what size heel do I need to have? Let's just say I'm standing on 1 foot and I have a heel. What size heel do I need in order to puncture someone's skin? The fate of the world depends upon this. There it is. All right. Well, I know that if I'm just standing there, then the force that I would be applying would be my weight, which we calculated last time. So I know that the pressure, 6.9 times 10 to the 5th pascals, is going to be equal to my weight, if I'm just standing there again, which is 900 something,
979.
979 newtons, divided by, well, the area, basically the cross-sectional area of the heel. So the math problem we're working on here, multiply the diagonal you know, and divide by the number left over, so 6.9 times 10 to the 5th. And that's going to be the area, which someone is about to reveal to me, to all of us. If Johanny tells me the answer before the rest of you, that would be embarrassing.
0.00141.844.
Is that what you said?
Yes.
All right, units?
Newtons over Pascal.
Okay, newtons per pascal is indeed correct. If we wanted to put it in something more traditional, we're using this international standard. Pascal is the standard, newtons is the standard. What is a pascal anyway? Did I say it again?
Newton meter squared.
Now you left the word out.
Newtons over meter squared.
Okay, or per.
Correct.
Yeah, newton meter squared, you're multiplying them, but there's a division there. So so Pascal is a Newton per meter squared, and so this whole thing just becomes meter squared. Now, not necessarily a convenient unit when talking about something that small. I mean, exactly how big is that? If I drew, is that too big or too small? Well, let's get it into square centimeters because that's gonna be much easier to work with. Square centimeters, I know to go from centimeters to meters, or sorry, meters to centimeters, I move it over 2 places. But I got 2 centimeters, or 2 meters that I am converting, so I do it again. And so I get 14.1884 centimeters squared, which is about a little under 4 centimeters by 4 centimeters. And there was a ruler around here. Probably underneath something. Maybe a little bit less, so very roughly. So I will put all of my weight on something that size, the world can be saved. It seems awfully big.
It does seem awful.
I'm wondering if, and I know this is going down a morbid road, and I'm really not quite sure why I'm doing it, but maybe it's the election. Anyway, I suspect I would break a bone before I broke the skin on that one, but I'm not gonna try it out. We'll just leave it for the theorists and the engineers to figure out. Questions? All right, so let's talk, so this is basically pressure, we've talked about density. Let's talk a little bit more about fluids. We're gonna bring up diving tuning. Now the reason I call it diving tuning is that